Okay, so today we're going to start with adding and subtracting fractions. So the main one that we're going to start with is when it has the same denominator. So if I give you a question, so I'm basically just going to go through examples, and then you can make notes on what I do if you think it will help you. I'm pretty much going to follow the same steps that I've given you already in your books. So if I give you something like, let's see, if I give you 3 over 10 plus 5 over 10 minus 2 over 10. Okay, so that's now our question. Do you see that they all have 10 as a denominator? So that means that we have the same denominator for all of them. So we're just going to keep the denominator the same since it is 10 for all of them. And then we're going to just put the numerators together with the signs. So we're going to have 3 plus 5 minus 2. And you only work out the numerator. So we've got 3 plus 5 is 8. 8 minus 2. You don't have to show all these steps, but I'm just showing you quickly. And then we've got 8 minus 2 is 6, and we've got over 10. But now we can't leave it like this. So remember, I always tell you, you need to keep it in simplified form. So when we simplify it, remember, we're just looking for the smallest equivalent fraction that it can become. So that would be called its simplest form. So we need to see what can divide into 6 and 10 equally. So I know that 6 can't go into 10, so I'm going to try something smaller. 4, can 4 go into 6? No, it can't go into 10 either. Let's try 2. So 6 divided by 2, yes, I can do that. And 10 divided by 2, yes, I can do that. So you need to get a whole number for each of these answers. So 6 divided by 2 is 3, and 10 divided by 2 is 5. So that is the simplest it can go. Nothing can go into these two. And that would be my answer. Okay, so with the same denominator, it's pretty simple. It's actually one of the easier ones. And then I just want to show you if you get a mixed number to calculate. So if you get 3 and 2 over 5 plus 2 and 1 over 5 minus, I don't know, 4 and 3 over 5. Okay, so let's try this one. So what we can do, you can either change all of these into improper fractions, or what you can do is you can put all the whole numbers together first, and then you can do all the fractions. So I like doing it that way, especially if it's adding and subtracting, but you can do it either way. So I'm going to go 3 plus 2 minus 4. Okay, and then I'm going to put all my fractions together. So it's 2 over 5 plus 1 over 5 minus 3 over 5. Okay, so I've got my whole numbers. 3 plus 2 is 5. 5 minus 4 gives me 1. So I've got 1 as a whole number. And then I've got all my, let's just make that longer. And you see they all have a denominator of 5. So then I can just add the numerators together. So it's 2 plus 1 minus 3. So I've got 1, 2 plus 1 is 3. 3 minus 3 is 0. 0 over 5. Anything divided by, or not divided by anything, equals 0. Okay, so basically we're going to just have 1 as our answer. Okay. The same as if you have something like this and it is bigger, just remember you just need to add to the, so say for instance it was a plus here. So if it was a plus there, then just remember, let's just change all of these to a plus. So 3 plus 2 is 5, 5 plus 4 is 9. So that's going to become 9 and 9. So then you're going to see 3 plus 3 So it's 2 plus 1 is 3. 3 plus 3 gives me 6. So it's now going to be 9 and 6 over 5. Okay? But now do you see that the 6 is, it's now an improper fraction because 6 is bigger than 5. So now you need to see that, remember, if you have 5 over 5, that's going to give you 1 whole. So we've actually just got 1 extra. So we've actually got 6 over 5. So that means we've got 1. So that's going to turn into 1 whole. So 1 5 over 5 can fit into there. And we're going to have 6 minus 5. So 6 minus 5 gives me 1/5. So that's what I'm adding onto it. So I've got 9 wholes. And I'm going to add on 1 1/5. So 9 plus 1 gives me 10. And I've got 1/5 left over. Okay. So just try that. Make sure that you understand that part. Okay, so the next section is similar things, but it's now when you have different denominators, but they're just multiples of each other. So if I have let's make this 2 over 5 plus 1 over 10. Okay, so if you see, 10 is a multiple of 5. So if I have to count in 5, so I've got 5, 10, 15. So 10 is actually part of the 5 multiple. Okay, so all I'm going to do is, this is the highest number. I don't need to make it any smaller. So 10 is the highest multiple, so I'm going to use 10 as my denominator. But how do I get from 5 to 10? So if I look here, I went 5 times 1 is 5. 5 times 2 gives me 10. So I'm going to multiply 5 by 2 to give me 10. And then whatever I do to the bottom, I have to do to the top. So 2 times 2 gives me 4. And then because I've already got 10 as a denominator over here, that means that I'm going to keep the number that's on top. So you can always say times 1. So 10 times 1 is 10. And 1 times 1 is 1. So you can always do it like that as well. Means exactly the same thing. Because it is exactly the same. You didn't have to change the denominator to get it to 10. It is already 10. So 4 plus 1 is 5 over 10. And we just need to make this in its simplest form. Okay, so simplest form, we need to see what can go into both numbers so that we can get a whole number out. And then we've got 1 over 2, so it's a half. Okay, so we've got that for multiples of each other. It's basically the same step. If we have to do something where it is a mixed number, you can also do the same step where you separate the fraction. And then you've got the whole numbers. So you can work them out differently like that. Or otherwise you can do improper fractions. So you can change it. So remember, if you're doing improper fractions, say for instance you've got 2 and 3 over 5, just remember you multiply the bottom, the denominator, by the whole number. So it will give you 2 times 5, 5 times 2 gives me 10, and then we're going to add the top. So 10 plus 3 gives me 13. So 13 is going to be my new numerator, and the denominator stays the same. And then you just solve it like that. Okay, so I'm going to do that quickly with another question, but I'm going to use a minus sum. Okay, so if I've got, let's make it number 3. So if I've got 3 and 2 over 5, and I'm going to minus, let's say 2 and 1 over 10. Let's try this. Okay, so 3 minus 2 gives me 1, and then we can do our fractions separately. So you can do it that way, or which I'm going to do and show you now is the improper way. So we're going to change it into an improper fraction. So 5 times 3 gives me 15. 16, 17 over 5 minus, and then I've got 10 times 2 gives me 20. 21 over 10. Okay, so now the same thing again. We need to do the same as what we did over here. Okay, so we just need to change this to the same denominator of 10. 5 times 2 gives me 10, so I need to times the bottom by 2, and I need to times the top by 2 as well. So 17 times 2, we're making our denominator 10. Okay, so another way that you can do it, if you don't know how to get it off by heart, and you don't have your calculator with you, you can always do it this way. 2 times 7 gives me 14, and then 2 times 1 gives me 2, plus 1 gives me 3, so it's 34. So you can always do it like that. Remember your normal multiplication, long multiplication sums. Okay, so 34 minus 21. Okay, so you can always do it this way as well. 4 minus 1 gives me 3. 30 minus 20 gives me 10, so it's 13 over 10. Do you see that 13 is still bigger? So we then need to make it into a mixed number again. So 10 times 1 gives me 10. Do you see that 10 is the closest to 13? If I go higher, and I go 10 times 2, I'm going to get 20. It's too much. So my whole number is going to be 1. And then 13 minus 10 gives me 7. What am I doing? Wait, 30 minus 10 gives me 3. My bad. Sorry. And then our denominator still stays the same as 10. And that's it. Okay, so we did multiples of each other, and then this one is just the same thing. It's just when it's not multiples of each other. So if I give you an example of basically a fraction where they have let's keep the 2 over 5 and just add a quarter. So you see the denominators are very different. They aren't multiples of each other. So if you want to and you still get stuck, what I suggest you do is you make a list of the multiples of 5 and the multiples of 4, and you see what is the common one that you can both get to. So you go 5. Okay, so with fractions that are not multiples of each other, I've got a question here that shows us where we've got 2/5 plus 1/4. So our denominators are 5 and 4. So what you should do is you get 5 and you get 4, and you look for the multiples that are the same. So you count in 5s and you count in 4s until you find a number that they both share. That is the lowest common denominator of those two numbers. So our LCD will be 20. It's the lowest common denominator that can both reach. So from 5 to get to 20, we had to count 1, 2, 3, 4. So we had to multiply by 4. I know some of you know this off by heart, but it's okay. So 2 times 4 is 8. Okay. And then we're going to put our plus in the middle, and then we're going to do the same thing where we are going to go 4 times what gives me 20? 1, 2, 3, 4, 5. 4 times 5 gives me 20. So what I do to the bottom, I do to the top. So 1 times 5 gives me 5. 4 times 5 gives me 20. There we go. Okay, so all we're going to do now is we are going to add the numerators together, and then if it's obviously something that can go into 20 as well, then we need to simplify it. So 8 plus 5, if you don't know how to do that in a simpler way, you can go, okay, well 8 is fine, but if you think of 5 is broken up into 2 plus 3, right? And 8 plus 2 gives me 10. And then I've still got 3 left over, so it's going to be 13 over 20. Okay, and then you see what number can go into 13 and into 20? nothing, so then you leave it as it is, and that is your final answer. Okay, obviously if you are going to be using something where it is mixed numbers, you can also do the exact same thing, where you can either work out the fraction and the whole number separately, or otherwise you can turn it into an improper fraction, as I showed you before. Okay, and then the second section that we're going to do is multiplying. Multiplying and dividing are pretty much the same thing, because remember, if you divide, this is why I'm putting this together. If you divide, remember, all it does is it turns whatever this is. So say for instance this is 3/5. All it's going to do is it's going to change it so that this 3 goes to the bottom and this 5 goes to the top, and you change this divide into a times. That's called the tip in times method. Okay, so you're basically still multiplying, you just need to swap it around. So I quickly want to show you an example. The main thing that I would like you to note is whenever you have a mixed number, they go into improper fractions in this section. This always turns into, it just makes it easier, an improper fraction. Okay, so I'm going to do one with the multiplying and one with the dividing. So I'm going to quickly do a common fraction, and then after that I will be doing a, what was I going to say? After that I'll be doing a mixed number so that I can show you the difference. Okay, so I'm going to do multiplying of, let's go 5/7 times 2/3. Okay, so all we're going to do is, because they don't have anything that can go into each other, so we can't see if 2 can divide into 7 and vice versa. So you always follow these little indicators. Okay, so can that go into that? Can that go into that? Can it be simplified? No. So then all we're going to do is multiply the top by each other. So we're going to go 5 times 2, and the bottom 7 times 3. 5 times 2 is 10. 7 times 3 is 21. Can it be simplified? No, because 3 can go into 21. Okay, so this one's the last one I quickly want to show you. You just change this into a mixed number. From a mixed number into a improper fraction. So all we're going to do is multiply the denominator by the whole number and add the numerator. So 5 times 3 is 15, 16, 17, 18. So it's going to be 18/5. Keep the denominator. And then we're going to do the same here. 4 times 4 is 16, 17/4. Then you're going to do the same thing. See if there's a number that can go into each of these. So you can either do that to make it simpler. So 4 and 18, there's a number that can go into both of them. Or what you can do is you can just multiply the top and the bottom. So you can either do this, 18 times 17 over 5 times 4. So you can do it like that. Okay, so you can do it that way. Or what you can do is you can see, well, 2 can go into 4. 4 divided by 2 gives me 2. And 2 can also go into 18. So 18 divided by 2 gives me 9. So then I can go 9 times 17 and 5 times 2. You should get the same answer though, either way. Okay, and then just as a reminder how you do your multiplication, you can always do it, let me do it on the side here. So we've got 18 times 17. Okay, so you're going to take 7 times 8. Okay, so you're going to go 7 times 8. Okay, so we've got 56. So put down the 6, carry the 5. 7 times 1 is 7, plus 5. 8, 9, 10, 11, 12. Okay, so you can do it like that. And then because this is a it's a 10. So because you are talking about a 17 and it's not 7, you put down the naught for your tens, and then you just copy. So 1 times 8 is 8, 1 times 1 is 1, and then you finish it and you add. So 6, 2 plus 8 is 10, 3, and that's your final answer. So we're going to go here and write 306, and 5 times 4 is 20, and we try and see if we can simplify that to our simplest form. Okay, so we're going to see what can go into 20 and what can go into 306, and then we simplify it to the best of our abilities. You can do the exact same thing here. So when you're multiplying it out, you can go 17 times 9, 9 times 7, 63, 9 times 1 is 9, 9 plus 6 gives me 15, so it's going to be 153, yeah, over 5 times 2, which is 10, and then you try and simplify it if you can. Okay, otherwise, if you look at this, this will give you pretty much the same answer. So if you divide this by 2, you should get the same answer as that. Alright, so it's kind of like skipping a step almost. But yeah, that is it. And then your simplified answer is your final answer. Just see if it can be simplified. I don't think it can, but if it can be simplified further, then you can simplify it further. Otherwise, that is it. If you are dividing, it's pretty much the same step. Just remember to tip in times whatever comes after the divide sign only. Okay, otherwise that's pretty much it for fractions and multiplying and dividing and adding and subtracting.